Hello everyone, thank you for joining me again in this lesson number 15 from the Spring Fundamentals stream. If you are watching the event live, don't forget that you have a live chat there, so you can ask questions directly in the chat and I will answer them directly. And if you are seeing this event recorded afterwards, you can still ask questions in the comment section below, or you can find me on LinkedIn and Twitter and you can ask me the questions there and I will create separate videos to answer you. Now we are discussing about unit tests in this lesson number 15, and I can't state how important unit tests are. I won't focus a lot in this lesson on the importance, however, of the unit tests and strategies of using them, but mostly on the technical part of implementing them with Spring. And of course, as there are a lot of possibilities to choose from when implementing unit tests, I will choose probably the most used of the approaches, but there are chances that you might see unit tests developed in using other frameworks. However, what I wanted to tell you is that even though you might use some other approaches, some other frameworks, some other libraries to develop your unit tests, still the same concepts will be used. So what you see here in these examples that I will do starting in just a couple of seconds, the same things you will practically use if you choose, or if you will have to use other libraries to do your unit tests. So let's start as always by simply creating a new project. And of course it will be a Spring Boot project. As always, I choose the Spring initializers and the latest version, and then I will give it a group ID, and this will be Spring Framework number 15. And the only dependency that I actually need here is the web dependency. For the first project I won't even need a web dependency, but let's add it here. I will first start by implementing unit tests using just JUnit and Mockito for mocking. You will see immediately what this is, and then I will use also some mock MVC objects in a later example, so that you can see two approaches of testing that are generally very used. For the mock MVC I will practically need the web dependency, but for the first example I would actually need only the test dependency that will come out of the box, I think, in my project, so I don't have to edit explicitly. I have created my Spring Framework E15 project, and then I will check in my POM XML to make sure that I have everything that's needed. And yeah, just have a look here. We have the web dependency as well as the starter test dependency in the test scope, so this is exactly what we need for our unit test example. And moreover, now I will take the opportunity to show you. I have started with this in maybe the first lesson of this stream, where I have presented and introduced you the structure of the Maven project, but I haven't used the test directory until then. Now is the time for it. So beside the main part of the Maven project that we have used until now with its Java and resources folders, we will now use the test section of the project, where we will have the opportunity to write and run our unit tests. And for this test section you also have the test scope defined for your dependencies in Maven, so dependencies that you only need during the execution of the unit tests. And this is where by default I actually even have a class, and this is the class. Of course we will have in a normal project multiple classes like this, but this is a class in which you can write the methods that represent your unit tests. And here is actually where we will write our code, most of our code of today's lesson. But in order to be able to write a test, we have to test something. So let's imagine some functionality and write some functionality that we will be able to test afterwards. and then I can say just create a services package and create a repositories package as well. And I will just consider that I have a service. For example, I will call it a product service. And the product service will have some functionality that I need to test and for which I have to add some unit tests. And that's a normal bean just annotated with the stereotype annotation at service. And then here I will just consider that I take from the repository, so I just take from the database some product names, and for some reason I just have to return the list of the names that have for example an even number of characters. It's just a very dummy algorithm to have something that we can test. So in our repositories then I will add a repository, product repository. Of course we only imagine the connectivity to the database. Here I don't have a database because I want to make the example as simple as possible. You don't have to concentrate now on anything else, just the functionality, the very poor functionality that I'm writing here to understand what's happening, and then we will just focus on the syntax needed for the unit test. And after we write our first test, then we discuss why is this important in our project. So why do we actually have to write unit tests? And this is again really important. I can't tell you in just a few words how important it is to have unit tests and to have your project correctly tested. Whenever you do something, you will feel the need of confidence that when you change something, you don't break something else, and that's what unit tests provide you. Okay, so here to just imagine that I have in this repository, I take from the database some products, and then I have a method that returns a list of strings, and these are the product names that I simply get from my database, and I will just return some array as list of names. And in this case my names will have some of them an odd number of characters, others will have an even number of characters, and I can just stay with this. And the reason for why I do this is now my algorithm that I will create in the product service. Here I just return the list of again the strings which are the names of my products. And then the reason for why I use the repository is that I want to get all the product names from the repository, but I only filter those that have an even number of characters in the name. So get product names with even number of characters. So it's just a very simple demonstrative example. For that I have of course to inject my product repository, and that will be, I need to use AutoWired for that. And then of course I will take the list of strings from the repository, so that's the names from my product repository, get product names, and then I can simply parse name by name, and for each of them, if the length is even, then I will just create a list of results. And yeah, I know what you're thinking, what an ugly code. Is exactly what I want to do. Actually, I will write this code in the very Java 6 example way, let's say, and then I will actually refactor it after I write the test. So this is my plan, is part of my plan what I'm doing here. That's why I'm writing just such an ugly code, so I can in the end prove why or one of the reasons for why unit tests are really important. So now I just return my result, and as you can see here, What my algorithm is doing is that I'm getting from the repository the list of product names, and those are the product names from the database, and for some reason I want to filter those that have an even number of characters. So I parse each of the names, and when I get one that have the length of the name in even, then I add it into a separate list that was defined empty previously, and then I return the result. So I want now, as a developer, to make sure that if somebody in the future will change this functionality, will change the logic, will change my logic somehow, for some reason, maybe it is only a refactor, maybe some new syntax appears and it's easier to write, and you want to eliminate the boilerplate code, or simply you just have to eliminate some case and change the responsibility of what I'm doing here, then I want to make sure that those folks that will change this code are aware of what exactly cases are they changing. So I want to write some tests in order to make them aware when changing something. If one of the important cases were affected, then I want those tests that represent the cases to fail, such that they are aware what they have changed, because that way they might see two things: one, that they might have changed something that didn't need to be changed, or they might have changed something and that's fine because it's really that part of responsibility that had to be changed. So in both situations it is important, because you make them aware that they did the correct thing. So that's why we want to write the unit tests, in order to cover these cases for my method. So I have the functionality here. So once I have written my functionality, of course this would be somehow used in a controller. From here I don't care anymore, it's just a demo example, but I want to test it. So I go back to this class, and yes, usually you would give it a proper name, and the methods will need to have a proper name and description. That's something that's related more or less. I wanted just to show you the technical stuff of unit tests now. So what do I really want to do now? So I have to find in my method here which are the cases, what could actually happen, such that I can test the flows that are important. For example, one of the cases that I could see here is what should actually happen if this list is empty. So I can take into consideration the aspect of what happens if this list is returned as a null, or I might think that I'm using, for example, a Spring Data repository where you actually know that the list won't be returned as null, so I want to skip that case. So for example, let's say that I want first to test what happens when I don't get anything out of the database. So I want to test what happens if this list of strings is empty. And then the next step would be that I want to check what happens if I have names, and that they might be situations in which all the names have an odd number of characters, all the names have an even number of characters, or you want simply to directly test the case in which you have both odd and even number of characters, which will be done by us now. So let's start with the first method, and then I can simply use this one and name it something like no products returned test, and this would be actually our case now. And in order to do that, in order to test the method, then I have to call the method. So if I have to call the method, the proper way to do that in Spring would be to take it from the context. So that's exactly what I'm doing. I will just declare my attribute here of type product service, and then I will auto-wire it using the auto-wire notation that you already know, and then I will call the method. So this is the method that I want to test. I will just call the method and get the list of strings that is the result. And then of course I have to think what should actually happen if this method is called for my situation. Well, if I don't get any names from the database, of course the result should be in this case an empty list. I don't expect an exception in my case. I simply expect to have an empty list as a result. So if in your situation there is another expectation, of course you just choose exactly your expectation. But on my example here, I simply just consider that if the database, if from the database I don't get any kind of name of a product, then I should see this is an empty list. And at the end, to be able to check the result, I use the assert methods. So I simply write assert, and we have different methods. We can use assert equals if we want to test if an expected result is what we have, is what we got, or we can use simply assert true or assert false. For example, in my case, probably the best choice would simply be to use the assert true method, and then you have to import it. Usually we use a static import for that, so that you don't see the name of the class every time in front of the assert. And if you for example have an IntelliJ, you can automatically import static the method, and it would be practically this assert method from JUnit. And then you just say assert true that the result is empty. So this is your expectation. If the result is empty, then it means it's correct. If the result is not empty, then the test should fail. Well, what I've done until now is just calling the method and asserting the result, but if I would run the test at the moment, I actually use the method completely that will go and call my repository, and then it will actually call the database. Of course, in my case, I just imagine that, but it would happen if this was a normal flow. And that's not really fine, because this is not a unit test in this case, and this would not even work, because where did I actually say that I don't have anything from the database? I didn't say that. It's nowhere. So in my case, I would actually just call the real method, and I might get things from the database. In my case, I will actually get exactly this list, and then the result would be that my test will actually fail, because if I run it, which I can actually do by in a lot of ways, but one of them would be just to press on the small green arrow here. Then if I run it, then I will actually get the list of 4 names, and then my result of course won't be empty, because I have there 2 of them that have an even number of characters, is this AA and the CCCC, and the result will be that the test will fail, and the failed test looks like this. You have a message in the end here telling you what's wrong, and yeah, you have to see what happened. But in our case, we don't actually want to see what happened, because we know what happened. We didn't assume anything, we simply called the method, and that doesn't happen in a unit test, because an unit test is called a unit test because it simply only tests a unit of the program, which is the method in your case, and it actually only tests a case of a unit of a program. So it should only test a flow of logic of this method in my case. But if I look carefully, I will see that actually what happens is that I don't test only this method, because if I leave it like it is, it will go also inside this method here. So that's wrong. That's not a unit test anymore. How can I do that? I assume something that happens with this method, rather than going and testing that method as well? Well, I have somehow to mock my dependencies. And when I say mock my dependencies, it actually means create a fake object representing your dependency that you can manipulate, such how you will just, depending on the case that you are testing, tell the mock what or how should it behave, and then test that the logic of your method behaves as well in an expected manner. So then I can create a mock of my dependency, and the dependency usually in an application like a Spring application are very easy to spot, because they are actually the attributes, and they are simply called inside the method to do something. So in my case, the product repository is clearly a dependency of this behavior I'm looking at here. So I will just have to create a mock out of my dependency, and then I will tell this mock that I want, in my case, to return no objects in the list, and then I assume that there are no objects in the list, and I will expect as well to have no objects in the list that is returned by the method. So in order to do that, again, I can do it in multiple ways, but one of the most used is the given method, and I can say given that, and I need to actually declare my mock here first, private product repository, which is my mock. Be very careful, because it is a mock and not the real object. You will not inject a value using autowired. If you do so, if you inject with autowired like you have done with the product service, then you will really get the exact real object, and it won't be a mock that you can manipulate. If you want it to be a mock, if you want to be a fake object that you can manipulate and tell it what to do, then you have to use the mock bin. And again, it's not the only way to do that. There is also a mock method that you can use. Technically speaking, there are so many ways. I wouldn't be able to show you in just one video, but believe me, it's not important to know all of them. It's important to understand the concept, because afterwards you will be able to understand and work with any kind of a way of writing unit tests, I promise you. So in my case, I have created my mock. Then after I have created my mock, I will tell my mock what to do. I will tell it that for this method, get product names, and be very careful to import the given method. Again, usually you will use an import static, because you can see how nice. You only just have to then see the name of the method and read it very easy, rather than seeing in front of the name of the method BDD Mojito or assert for the assert true. Then if you have also the name of the class in front of the method, it makes it much difficult to read. And if you don't have it, if you use an import static like we most of the times do, it's very easy to read it. So you just say will return, and then in this case I want an empty list, so I can just use the collections empty list, for example. Yeah, I think is the easiest way. And what I have done is I now mocked my dependency, and I have a fake object that is injected in the product service when running this test. And what will happen is that this mock object will actually behave the way I have told it to behave here, like will always return an empty list. So you can even read very nicely the test here. You see, you always have steps. You have assumptions. So given that something will happen with the dependencies, when I call the method, then I get a result, and something should be happening as well. So this is what I expect. This is the call of the actual method, and this is my assumption. This is what I assume to happen. So this is how a test should look like. Should be always easy to read. Assumptions, call of the method, and then expectations. And if the expectations are okay according to the assumptions when you call the method, then that is a test that is okay. If it is not, then it means that something is wrong. And now we will just simply run the test method, and we will see which is the result. So we expect that the test will now run successfully, and if that happens, actually you will see a green test here showing you that everything is fine. So this is exactly what happens, and that means that our first test case is okay. So again, what could actually be the next step for us? We could create then a test that show us that everything is fine as well when you have names returned from the database. So let's actually do that, and I will say public void more products are retrieved or are found in the database, and I will keep the name short, and then I annotate it with the tests. By the way, I left this annotation at the end because I want you to present all the important annotations regarding one of them, and maybe the most important is the @test annotation that marks the methods that represent the tests. And then I will have practically mostly the same thing. For example, here I will actually have to provide a list, and then I will say this is my input. So when the input will be AA and BBBB and CCC, then if the product names, if my dependency would return this input, then when I call the same method, the result should have two elements here, so it's not empty anymore. And then I wouldn't use the assert true, I would actually use the assert equals in this case, and I would say then 2 is the expected length of the result. And I can even check that I get the correct elements. That really depends on how deep you want to go with your tests, and this is something that is more related actually to the functionality that you are developing. So I think with this you have already understood what are the main parts and how to write a unit test and what a unit test is. And if you didn't if you didn't see tests until now, and you have more I don't know misunderstandings or questions and I didn't explain them well, please leave me a question, or if you are watching the event recorded, you can leave me a question afterwards, and I will explain it again. But the idea is that a test is always for one of the flows, and you will always have an input, and then you will have some assumption. You will call the method that represents your tested behavior, and then you will assert something that on the result, and this is the expectation, what you actually expect to happen. We expect that the size of the result is 2 in this case. Another thing that could be important is that sometimes you don't necessarily expect a result. You might even have a void method, and the expectation would be that a specific method is called. What would happen in that case? So for example, what if in the product repository we have some kind of an operation, like we have to add that name somewhere, and we just add product here, and we have add product with a name, and instead of actually adding the name in a list, or together with adding the name in a list, then you would say add product of name. And what would actually happen in this case? How can you test that this method is called? This is also a situation, this is also a case. You might not even have a returned result that you want to test. You want to test that a specific behavior is called. And if you want to do that, you will probably, in this case, use the verify methods. So your test would actually look like you could have an assert as well, but you will also have a verify and that's, for example, the verify mojito method. You just say I want to make sure that at least once, or once, if I want I can say only once, then the method add product was called. In my case it actually won't be only once, it would be twice, because the way I have written it would be inside the for, so it would be exactly equal to the length of the result. And then the name here would be the name of the values. So I don't actually have a name to provide here, but I can say any string, and then I won't test actually that the input that I provide is correct, but I test at least that the method is called. And depending on the complexity of your test, what exactly and how deep do you want to test it, you would practically need to specify also the values if you are interested, or you might simply leave it like this, where you only where you only test that the method and you assume that the values are correct. And again, this is really depending on what you are testing. Okay, I will comment this out now, and the same I will take this out here. It was just to give you also this insight. And now let's see, what would this be useful for? Why would I actually do such a test? So for example, the way I've written the code here is poor, and we have a lot of boilerplate code, and for sure using at least syntaxes from Java 8 that are already for a long time, we could enhance this code. But if I would have a real code, that would be even, I don't know, even longer than this one, and more difficult to understand. It would be a little bit difficult for me to consider refactoring it, because I might think that it is really possible to break a case without even noticing. So there is a possibility that I will break some case and I won't notice. And if I have unit tests, actually I know that when I run them, all the cases were covered. If all the logical cases were covered, then I can always run the unit tests, and then I will see that the unit tests would actually run. And if I change something, I would assume that running the tests again will tell me if I have changed anything and something is not working anymore. So for example, let's now try to change this code and make it a little bit more readable using some streams and Java 8 approach. And in this way, it's actually very easy, because the only thing that we need is just to filter out only the odd length valued names, and that would be a return. And I will just take a stream out of it, and then I will use a filter. The filter would be that my name is of even length, and then I would collect this as a list. And theoretically, this now code should do the exactly same thing as the previous code, where I was using a for loop and an if decision statement, and I was creating a new list and returning it. So practically this now should do the same thing, and I want to prove that it's actually the same thing. And in order to prove that, I would actually run again the class with unit tests, and then if both of tests will show me green, then it means that at least the cases that I have tested work correctly. Again, the logic didn't change. So you can see how nice I can just reuse. Now I have changed the code, and to prove that the cases in my algorithm work the same as previously, even if I have changed a lot of code here, I just rerun the tests. If the tests show me green, then it means that I didn't change the logic. So I could refactor the code, make it look a lot nicer, and I'm also sure that I didn't break anything, which is really cool. Okay, so if I want you to prove now what happens if I, for example, make something, for example, I just by mistake put a wrong condition here, then in this case we should be able to see that one of the tests is failing, and then if one of the tests is failing, I as a developer would know that I probably have done something wrong while refactoring my code, but that's good as well, because knowing exactly which of the tests is wrong, then I can go exactly to that test, see what happens. For example, in this case I can see that it was expected to have the number of values 2, and I had only one value, and then I go and review my code and see what have I done wrong. Of course, there are situations, if you don't cover all the cases, there are situations that may fool you. For example, in this case, this test happens to have two different values, like two values of odd or of even numbers and one value of an odd number. But if I would have used an input that where I had two values even and two values odd, then I would still see again that the test was running correctly, even though it wasn't correct at all. So you have to be very careful. You really have to write tests. Here is just my demo example on how to write unit tests, but in a real application you really have to assume which are all the cases that might be affected and which are important, and then write correct cases, the correct tests that don't provide you false positives, for example. And false positives can be very tricky, because then you might think that you have written your code correctly, you have refactored your code correctly, but in fact you have changed functionality, and then it might be difficult to understand why or how did that functionality change. Okay, this is actually what a unit test is, and again, by this example I really hope that you understood how to write technically, or at least with this possibility, which are the technical parts of a unit test. You might again see them using different approaches and different libraries, but you will always discuss about an assumption, the tested method, a mock or multiple mocks, and then the verification and the assertions, and this is what you have to understand. Now, why are they important in a very short sentence? You can use them together with your continuous integration pipeline, so you can run them whenever you build, not only locally as I all do here. You will always run your tests also locally, but you can also integrate them with a continuous integration pipeline. And if you want then to do like this, this will help you by making sure that when you deliver something, some artifact, all the tests were correctly run. And if you have a good coverage of all the important cases, you actually know that whatever you change didn't affect, or there is a less chance to have affected what was working in a previous version. And that's really important. Also, you can measure the coverage, which is, again, I won't be the one telling you that a very big coverage as a number really means that you are fine. You have to be very careful, because if you have a big coverage but you have a lot of tests that can show you false positives, then that's not okay. But still, it is a number that it has to be taken into consideration, because at least it shows you if you are on a good coverage, and you have tested, at least touched most of the classes and lines of code. in IDE like IntelliJ and a plugin like Jacoco, and using a server like SonarCube, then integrated with your continuous integration pipeline, would help you to always keep an eye on the coverage and the execution. And for example, in IntelliJ, you can just go and specify run your test suite or all the test suites if you want with coverage, and then it will automatically calculate your coverage as well. And moreover, you will see on the tested method which are the lines that have been touched, which are the lines that that have been touched by the unit test, so that have been tested as well. So let's see what happens. I have just run it with coverage, and then I will see here the numbers of the coverage. 2 out of 3 classes were tested here, and that's true because actually I've never tested any of the lines of the product repository, but you can see that I have tested all the lines of the product service. And then it's 1 of 4 methods were tested, because probably there are in total 4 methods in the application and I have only tested 1 of them, and that means actually 60% of the lines. And you can see here with green, really nice, that all the lines were touched of this method were touched at least by the unit test. This doesn't mean that the method is completely tested. This doesn't mean that I have touched all the cases, but at least it means that I have touched the lines. And with a good eye, with an experienced eye of a programmer, could see if one line is missed, what are the cases that were missed, and this really helps you into finding out if you have missed an important case, and you then implement a test for that case as well. Okay, and to end up with this part of unit tests and mocks, I also want to tell you about the other annotations that you will see together with your tests. So these are the before annotation, BeforeClass annotation, BeforeClass, and then after, and then AfterClass annotation. So these 4 annotations can be placed on methods that you would like to execute before each of the tests. And by the way, in JUnit 5, which is JUnit Jupyter, this annotation would also be called before each. So you might see it in the future like this instead of before, and this will also be named before all. And the same with the other 2, it would be after each and after all. Before, it means that the method annotated like this will be called before each of the tests. And then you also have a before class, and the before class is a method will be annotated on a method that you want to be called once at the beginning. So for example, in this case, if I'm just creating a before method and I print something out from here and I annotate it with before, and the same I will actually do public void before class. And you have to be very careful because the before class should be on a static method actually. So you will see that the before class will be displayed only once at the beginning, but the smiley face will actually be twice because I have 2 tests. So if I run both of them, then the before method will be called before each of the tests. The before class will be called only in the beginning. So this is used to set up your test environment. If you need to set up something before all the tests or set up something before each of the tests, then you can use some separate methods for this responsibility, and then you annotate them with before class and before. And then at the end you can have the after methods, and the after methods would be called after each test and again after all of the tests at the end if you need this. So these methods help actually you to decouple this responsibility that would be part of each of the tests. You can just put the code in only one place and you know that it will be executed before each of the tests. And now I will just run again the tests, and I want to see in the console the smiley faces so that you can see indeed that this one was only once displayed while this one will be twice because I have two tests. And the same thing again for the annotations with after and AfterClass. So if you will use them, you will see that after the execution of the tests you will see them similarly. And you can see that I have here two smiley faces. Somewhere before it will be the other face that I have printed from the before class, and this is only once because this is run before all the tests, while this is twice because this is run before each of the tests. So I have to test. I will see in the console twice the smiley face. Good. And with this I will actually end up with this unit tests. And then I will go to the integration tests and I will try to show you how to call some integration tests with mock MVC. And in order to do that I will actually create a controller package. So then I will just create a class product controller. And then in the product controller that is only a REST controller for me, I will assume of having, for example, a method that returns a product, and that will be a product that I get. And I would actually want to have a product to prove something, so that means I will also create the product class very fast. So that will be a product with, let's say, a name and the price, and price. And of course I will add getters and setters to this, and then I will return a product that I just create here. But in a normal real case scenario, you can imagine this is actually coming from a database or is coming from one of the use cases. Doesn't really matter. So I just say here I have actually the name. I can take the name from for example path variable to be nicer, just for the sake of the example. So this is a path variable name, and then the name will be from that. And then to simplify it, I will just set a price to 10. And yeah, this is the case. And the idea is in this case to call the endpoint as I would do from Postman, for example. Because the way I would test this now to see that it works properly, the way I believe it should work, I would use Postman and I would simply call this endpoint in order to check that it has a specific result. But what if I want to actually implement some automatic tests that do the same? Wouldn't that be nicer and easier for me to just run all the cases and check they are working properly? Well, we could call this as being an integration test. And in order to yeah, it is a lot of discussion about where is the limit when you have an integration test and what the integration test is and what the integration test is not. Because in the unit test example, it was pretty easy to tell you just that you test the method and you mock out all the dependencies, and then that's a unit test. But if you have an integration test, then what you will see is that you actually have more borders. It's not that easy anymore. So a lot of times you will see programmers discussing where is actually a border of an integration test. Is the border of an integration test the database? Should we mock the database, or should we actually use the database for the integration test? Should we use an embedded database, or should we use the proper actual used database for development? In my opinion, I'm really flexible, and I will actually say that all of these are integration tests as long as you have a larger border than only testing a method like we have done previously. So I consider an integration test to be any kind of test where you actually have more than one border. You don't test only one unit of the program, then that's an integration test. And that's an integration test. You can mock the repository, for example, and it's still an integration test. So in my case, if I call the endpoint and I simply leave the flow and I only mock the repository, then I can consider that an integration test. And if I want to go even deeper, then of course I can use an embedded database. And why would I use an embedded database in a test? Maybe you are asking, okay, if I mock the repository or if I don't mock the repository, which are the advantages and which are the disadvantages? If you use an integration test in which you mock the repository, you have the advantage of speed of execution, but you have the disadvantage of missing the execution, the actual execution of the, I don't know, for example, JDBC or Hibernate, whatever you have there. So you don't test that as well. So if you want to also test that, you probably have to come with a database, and most probably you will have an embedded database that will give you enough performance, but as well will leave you also test the part of integrating with the database. You can use actually a real database, not an embedded one, but in that case you have to be very careful because you are using network, and network is not 100% reliable. So if you are actually using a real database, you might have the situation in which your continuous integration pipeline will fail, not because the application has something wrong, but because the network, which was unreliable, didn't allow you at some point the connectivity to the database, and then the integration test failed because the database was not accessible, and not because the application has a problem. You have to be really careful. But an integration test, in my view, is any kind of test that have more than one border. If you don't test only an unit, then it's an integration test. For example, here I'm already, even by testing this method, I'm an integration test because I will call the endpoint, not the method directly, the way I have done it with the unit test. And usually I use it at least until the repository. So I test all the logic with all the services, managers, and I do only mock proxies, which can be proxies to other microservices, because I don't want in such a test to also test the connectivity with another microservice or another system. And I also mock the database. And if I really consider that's important, I use an embedded database for testing the database as well. But usually, in my experience, or at least what I've seen until now, it was proved that always the decision of mocking entirely the database was a better approach. So, but again, that will actually be your decision. Now, I wanted to show syntactically how would you actually test that, and let's just have another method here, another class here. And I will just use the same one, and I will name it integration tests. And yeah, what I actually don't like is that I now have a lot of methods, and then I would actually have to write, and maybe I want to show you why I do that. First, my need is to call the endpoint, so I need a client that is able to call an endpoint, and that kind of a client is provided with the mock MVC class, and the mock MVC will allow me to call the URL that further will call the action of the controller and so on in my application, and I want to auto-wire such an object. But if I try to do so, by default you will see in an intelligent IDE that you actually don't have any bin in the context of this type. So by default you don't have this option, but you can use the auto configure mock MVC, and then when you add this annotation, automatically the error disappear, because this will automatically configure mock MVC, so you will have a bin in the context of this type. And then I want to actually test my method, and again I have to write a test method for the case, and then I again have a lot of cases for each call that I do. I won't bother you a lot because we don't have anyway a lot of time, but let's say in this case, let's just say that I want to test the happy flow of the get product method, and that would be, this is my test, and what I say is, yeah, perform a call on the following URL, and then I have to be specific here which is the URL that I want to call. Of course, if the method that I want to call is this one, then I will actually have to use a get and to call this URL here. So I will say get, and then I will have the URL that I test. So is this one. Be very careful because we have a path variable, and because we have a path variable you have to provide also the value, because now you are calling. So as in Postman, for example, you have to provide the needed parameters. And then I have imported this get method statically. We usually use the static import in this case to make the code easier to read. And then you say perform this get, and then you just and expect, and again the same way I have told you in the situation of the unit test, where you have assumptions, the call itself, and then expectations. Then you have the same thing here. You have the assumption, you perform a call with get for this URL using the path variable value beer, and then what do you actually expect to happen? Then you can, for example, expect that the status is okay. Usually import static methods, and here is, be very careful also what kind of methods. Sometimes you have methods with the same name, you have to import the correct one. And do I have something else? Yes, I maybe want actually to test as well the result. So in this case I can use and expect again, and of course I can use and expect as many times as I want. I can make it look a little bit better like this maybe, and then say JSON path, because you actually will get a JSON back, and you know that you have used that with Postman until now, I'm sure, and you know that by calling this method your body will come back as a JSON by default. That's the default of Spring, the way it is configured. And then you can use this JSON path to specify which path would you like to test, which path for you should be the one that you are testing. And you can use an expression like this. You say the name has the value, and which is the value for the name, and that in my case would be beer, because this is the value of the path variable. And you know that the logic of my endpoint would be that I here pass the name, and then the name is used for the product, and then the product should have the name provided through the path variable. So that's why here the expected value is beer, because I have provided beer here as a path variable. And then you can do the same thing with the price, and you say and expect, and again the same thing, and you say and expect the price to be, and let's see which is the price. In our case it is 10, so it will be actually as a double here, that is 10.0. So that's actually, and of course we have to also treat the exception. Now to make it shorter, I will simply throw it out of the method. And what happens here is, again, you have the same way of reading your test. You do with mock MVC perform a call of a specific type that will be get, post, put, delete, depending on the method. Then you specify, of course, you need to specify the URL that you are calling. You have to specify the path variables, query parameters, request parameters, or even the request body if this is available. If you have a post call, you might have a request body. And then you specify your expectations, and if these expectations match, then you will have a succeeded test, and if the expectation do not match, then you won't have a succeeded test, and you will see what happens. For example, maybe I have expected that the price value is 5, and we know already that the price value is 10 because that was hard coded in our method. But if I expect here that is 5, then the test will not run, will not be a success, because then one of the expectations is wrong. So if this expectation is wrong, then the entire test will fail, and then we will have a nice message. You see the test is failing, and we have a nice message telling us what's wrong, what is the request that has been done, and what's wrong. Actually, the status was 200, so the endpoint is fine and everything else is fine, but you can see here that the body return had the price 10 and you expected it to be 5, and that's actually what's wrong. And with the same approach, you could actually mock things. So if I have a dependency that's providing my price, again, the same way we have done in the unit tests, we could use the given method to do assumptions. So for example, if I would just assume some values come from the database and I want to mock the database, I can simply mock the repository, and then I call mock MVC, and it will use my assumptions that I provide before the perform of the call. And that way I can mock the database if I have a database, and I can just provide with using a mock whatever I want to be assumed that I get from the database, and then test my cases only inside. And again, this depends on how deep would you like to go with your integration test. If you want to simply mock out completely the database, you can use the same approach we have done with the unit tests, like here, using the given method. And if not, you can use, for example, an H2 embedded database for that, and use it up to the database and store data and so on. Good, the time is out for this lesson, and so most of the things that I wanted to show you, there are a lot of details. I could show you a lot of details about how to use mock MVC and how to use mocks, but this was not actually the plan for the lesson. The plan for the lesson was, and I hope I am successful with that you understood what a unit test is, at least some of the reasons for why you should write unit and integration tests, what's the difference between a unit test and the integration test, and these possibilities that I have provided you with to write both unit and integration tests. As I've said, in your application you might find out some other ways in which you will write the tests, but you will always find the same structure, the same logic, and the same concepts. I will only end now my lesson with an advice. Always use unit and integration tests and test your application roughly. It's really important for the quality of the code you want to provide. Thank you very much for listening. I'm waiting for your questions. If you have questions, you can always leave them as usual in the comment section if something is unclear, or if you want more details on something that you didn't understand. I'm waiting for your questions, and I will create separate videos to answer you. Thank you very much for listening, and stay tuned for new lessons and new videos.